Chapter 30, we're continuing our look into exponents, and from the previous chapter we talked about three rules that we can use to simplify exponential expressions. Okay, we had the product, quotient, and the power rule. And what we did is we mostly dealt with positive exponents, and I think in one instance we actually ended up with exponent of 0 when we were applying the quotient rule. And so that's what chapter 30 is about. We're gonna talk a little more about zero exponents and negative exponents. So where or what situation does a zero exponent come from? Okay, well, it comes from a situation where we have two variables, the same variable, x, and they each have an exponent, and their exponents match. Okay, so for instance, x to the fifth divided by x to the fifth, if we were to apply the quotient rule, typically what we do is we pick the larger exponent and we keep that variable where it's at, and we move the smaller exponent to it and subtract it. In this case, they're equal. And what happens is, let's say we just move this 5 to the top and subtract it from the other one, we get an x to the 0 power. And so how do we interpret this? We know that anything raised to the first power is just itself, and that applies to variables, or it can apply to numbers as well. 5 to the first power is just a 5. So if an exponent isn't written to the upper right of a number or a variable, then it's understood to have an exponent of 1. Okay, so what do we actually get when we divide any non-zero number by itself, which is what's happening here. We're taking an x to the fifth and we're dividing it by itself. And so this is similar to the situation of if we were to take just 5, the number, and divide it by itself. 5 divided by 5, we get 1. If we had a variable y divided by y, we get 1. Anything divided by itself is 1, except for 0. And so if we're expecting to get 1 when we divide something by itself, then in the case of variables with exponents, once we apply the quotient rule, we get x to the 0, and so these two items should be equal. Okay, x to the 0 should be equal to a 1. And that leads to any non-zero number. If we raise something to the 0 power, we get a 1, because it simply comes from the situation where we're taking something, it could be anything, and dividing it by itself. So for instance, if we did some more examples of this, we could say, what about 3 to the 4th power divided by 3 to the 4th power? Well, exponents are the same and the bases are the same, so we could reduce this to a 3 to the 4 minus 4 and say this is a 3 to the 0 power. But from the very beginning, you should have noticed that we're dividing something by itself, and this should equal 1. So it doesn't matter what number or variable the 0 power is applied to, we will always get a 1 as a result. Okay, now that's not to say that if you have an expression and a 0 power is placed anywhere in the expression that you're going to get a 1. It just means that whatever the 0 is applied to will work out to be 1. And so in this case, the 0 is being applied to this set of parentheses or anything inside of it. So we can write this as a negative to the 0, or a 7, or times a 7 to the 0, and we just get a 1. Okay, a negative to the 0 power is same situation as a negative 1 to the 0 power, so raised to the 0, this would be a 1. 7 to the 0 would be a 1, and so we'd have 1 times 1, and we get 1. Okay, but it's important to realize that the 0 applies to both the negative and the 7. In this case, the 3 and y are not included in parentheses, so the 0 only applies to the y, and so y to the 0 ends up being the 1, and then we take that result and multiply it by the 3. The 0 did not apply to the 3, and so in this case, our answer is 3. B, the 0 is only applied to what's in parentheses, and so the negative isn't involved with the 0 exponent, so we just bring it over to the right, and then 1/7 to the 0 power leads to our 1, and we put it right beside the negative, and so in this case, well, we're finished. We get a negative 1. Okay, and the negative was simply brought over to the right. Okay, so the point is, pay attention to what the 0 is being applied to. Okay, if there are no parentheses immediately beside the 0 power, then it only applies to the number or variable that's directly in front of it, or to the left, you could say. So this 0 is only applied to the y, so y to the 0 is 1, and then we would bring over the x to the front, and so we have an x times 1, which is just a 1. In C, we only have one variable, and it has an exponent of 0, so we do actually just get a 1. And then for F, it's similar to E. Okay, we had an x and a y in E, but the 0 only applied to the y. And now here we have a 0 power, but there's parentheses in front of it, and so this 0 gets applied to the x and the y. So this works out to be 1. You could break this up by applying the power rule and saying that this is a 1, okay, x to the 1 inside the parentheses, and then times the 0, the power rule, from the outside. And then for the y, we had an exponent of 1 inside, and we multiply that by the 0 outside, just an application of the power rule. And then what is 1 times 0? Well, it's 0. Same case for the y. And so then for each variable, we just get 1. And 1 times 1 is 1. Okay, in the previous chapter, what we said when we were dealing with the quotient of two like variables is that we apply the quotient rule by picking out the larger exponent, which is an x to the 5th power. Okay, we have an x on top and bottom, it's just that their exponents are different. And so we pick out the one with the larger exponent, and we subtract the smaller exponent from it, And in the place of the exponential expression that we disregarded or moved, we replace it with a 1. And in this case, we end up with an x to the third power, and our exponent's positive. Well, it actually works out to where we can move either exponent. We don't necessarily have to move the smaller one. We could have moved the 5 to the top and subtracted it. And in that case, we would have an x to the negative 3 instead of a positive 3. But you'll notice that now the x is in the numerator versus our previous answer where x is in the denominator. And so what we have to conclude, since both of these expressions were derived from the same starting expression, is that they're equal. 1 over x to the third power is equal to x squared over x to the fifth. That's where it came from. Which is in turn equal to x to the negative 3, should we decide to move the exponent of 5 instead and subtract it from the 2. So these are equal expressions. All three of these are interchangeable. Alright, so what that tells us is that if we move an exponential expression from the denominator to the numerator, or from the numerator to the denominator, then we change the sign of the exponent. Okay, so if we look at A, the negative 1 exponent is applied to the negative and the 7. This negative is part of the coefficient. This negative is a part of the exponent. We're only going to change this sign when we move the negative 7 to the bottom, this negative stays with the 7, and the 1, the exponent, becomes positive. And so in the end, we could have written this as a 1 over a negative 7, or a negative 1 over a 7. And we already knew about this. If we have a negative in front of a number in a fraction, we can take it from the denominator and just simply move it to the numerator. Okay, as long as ultimately we don't change the sign of the 1/7. Either way, it's negative. Okay, the important negative here is the one that's involved with the exponent. We took the negative 7 from the numerator and we moved it to the denominator, and so the negative of the exponent disappeared. Alright, C, we have a negative 2. This is not a negative of the exponent, and then times an s to the negative 5th power. There are no parentheses as there were with the expression in part A, and so the negative 5 does not apply to the negative 2. It only applies to the s. And so what we do is we leave the negative 2 alone. We only move the variable that the negative exponent applies to. So we move the s to the denominator, and then we can write the exponent as a positive number. Okay, B, we're going to sort of take a roundabout way. In B, we have a fraction, and it's raised to a negative exponent, 2. If we wanted to, we could apply the power rule first, which says that we have a 3 to the first power inside parentheses times the negative 2, and then the 8 on the bottom, it also has a power of 1, and when we apply the power rule, we multiply it by the negative 2 on the outside of the parentheses, and so we end up with a 3 to the negative 2 and an 8 to the negative 2. Okay, if we considered each number 3 and 8 separately, we could write it this way. So we have two exponents now. We have a -2 on the top and a -2 down here with the 8. In order to fix that, what we do is we take the 3 and we move it to the bottom of its fraction, leaving a 1 in its place. And then we take the 8 and we move it to the top in the numerator, and its 2 becomes a positive, and it leaves a 1 in its original place. And then if we multiply these back together, we simply get an 8 squared over a 3 squared. And if we reverse the power rule, then what we can do is simply write this as an 8 over 3 and then move the 2 to the outside. It's just the reverse of the power rule. And so if you compare this to the original expression 3 over 8 to the -2 versus 8 over 3 to the +2, you see that when a negative exponent is applied to a fraction, we can simply just flip the fraction and make the exponent positive. Alright, D, we have 1 over 5 to the m to the -4th. Okay, it's important to realize what the -4 exponent is actually applied to. In this case, it's only applied to the m. So we could separate these and write this as a 1/5 over m to the -4. The 1 and the 5 are fine. They don't have negative exponents, but the m does. And so to fix this negative exponent, we simply move the m to the numerator and the exponent becomes positive, and we leave a 1 in its original place. And then if we marry these fractions back together, 1 times m to the 4th on the top equals m to the 4th, and a 5 times a 1 in the denominator equals a 5, and we end up with m to the 4th divided by 5. So what you want to do is only move what the exponent is applied to when you're trying to change the sign of an exponent. Example 3. This looks similar to some expressions that we simplified in the previous chapter, except now we have a negative exponent mixed in it. What we did in the previous chapter is that we rearranged everything, because if you look carefully at this expression, the 3 is multiplied by the t is multiplying the x. We have no plus and minuses inside on the coefficient variable level. The only negatives we have are in the exponent. And that's just to say that there is no addition or subtraction, or division for that matter. So when things are simply just multiplied together, we can rearrange them. Okay, we can pick out our coefficients, 3, 6, and 4, and place them side by side. We can pick out our similar variables, t squared, and it's a good idea just to go from left to right so that you don't leave anything out. T, and then here's another t to the 7th. We'll place those side by side. And next we have an x here and then an x squared there. And then we have only the u variable left. And so for the t, the only exponents that add are 2 and 7. And we get a t to the 9th, 2 plus 7. This is the product rule. We have a t times a t, and so we add their exponents. 3 times 6 times 4 is, let's see, 3 times 6 is 18, And then if we multiply 18 by 4, we get 40 plus 32, 72. So we've taken care of these. We've taken care of the coefficients. An x by itself with no exponent is understood to have an exponent of 1. And when we multiply two x's, we can add their exponents. And we get an x to the third, which takes care of these variables. And now we deal with our negative exponent. So nothing new in this case with respect to the previous chapter, but now the topic of this chapter comes up with the u's, the negative exponent. And we still apply the product rule the same way we had in the previous chapter. 8 plus a negative 9, that's going to give us a negative 1 for the u. And so everything else just simply gets rewritten. We have a u to the negative 1, and this can easily be fixed if we prefer not to have negative exponents. We can fix that by simply writing the u in the denominator. And then the u is understood to have an exponent of 1 if an exponent isn't written, and it would be positive. Okay, so what we'll do is, instead of me rewriting everything side by side, like variables, coefficients, and whatnot, I'm just going to multiply it in my head. Okay. First we'll do the coefficients. 6 times 3 is 18. 18 times 5 is 50 plus 40, 90. Okay, we've taken care of the coefficients. We have a u variable here and there. And so we end up with a u to the 9 plus a 1. That takes care of those. Then we have two z variables here and there. And so we write 1z and then a negative 4 plus a 3. All of these numbers and variables are multiplied together, or coefficients I should say. So we've taken care of the z's. And our final variable that we have to deal with is the w, and we have a negative 4 and then an 8. So we add the two, negative 4 plus 8. We've used up all of our coefficients and variables. We'll go back and finish the addition of the exponents, and we get a 10 for u. Z ends up being a negative 1 for its exponent, but then the w is okay, and so we didn't have to move the w to the bottom. What we did here, instead of moving the variables first, we went ahead and applied the product rule. We added them, and so the w sort of straightened itself out because we added an 8 to it, and there's no more negative exponent for the w. The only variable that we actually have to move is the z, and we can move it to the bottom, and the 1 becomes a plus 1 on the bottom in the denominator, and everything else stays on the top. Example 4, we apply the quotient rule. Okay, and it doesn't specify whether we want negative exponents or not, and so we could write this two different ways. The first way, we could just say, well, I want my variable to be in the numerator. So in that case, I keep the b with the negative 8 on top, and And if I'm moving the b to the 7th to the top, then I would subtract 7 from it. Okay, whichever exponent we move, we subtract it from the other. And so this would become a b to the negative 15th power. If for whatever reason we did not want negative exponents, then we could just simply write this as a 1 over b, move the b to the denominator, and change the 15 to a positive number. Okay. Knowing how to handle negative numbers, I'm going to show you an alternate way, sort of an intermediate step that we could have taken with this quotient rule. We could have said, well, b to the negative 8 stays on the top. We didn't move it, so we keep the sign of the exponent. But we could move the b on the bottom up to the top next to the other b instead of dropping it. And if we move the b to the 7th to the top, then we have to change the sign of the exponent, and that becomes a negative 7. And so we've sort of taken a situation where we're calculating a quotient, and we've posed it in a product way. We've changed it to the multiplication of two variables instead of the division. So now we have a b times a b, and we apply the product rule, which says that we add the exponents, and so we say negative 8 plus a negative 7, which works out to be the same as subtracting the 7 as we originally did. We get a b to the negative 15. A negative 8 plus a negative 7 is a negative 15. Okay. So with any quotient involving exponents, we can write it as an intermediate step. We can rephrase it as the product of the variables, now that we know how to handle the negative exponents. Alright, so what we'll do is I'll keep the x for b. I'll keep the x to the negative 1 on the top. I can move the x squared to the top just by changing the sign of the exponent, and now we have a product of two x's. If I apply the product rule, that says that we add the exponents, and we get negative 1 plus 2, x to the positive 1. If for whatever reason we wanted the x in the denominator, then we could move the x, but then we'd have to change the sign of the exponent. Okay. And likewise, you could have applied the quotient rule instead of rearranging it as the product. You could have said, well, I want to keep the x on the top, and I write a negative 1. And then if I drop the x to the negative 2 on the bottom and subtract the negative 2 from the exponent on the top, just a direct application of the quotient rule, we subtract a negative 2, and so this ends up being a negative 1 plus a 2, and we still get an x to the first power, which is the same thing as just an x. Okay, part C of example 4. If we directly apply the quotient rule, then we could say I'll keep the y on the top with the exponent of 2, and I'll subtract the other exponent from it. And so one minus comes from the quotient rule, the other minus comes from the exponent itself. I end up with a 2 plus 3, minus minus is a plus, and then 2 plus 3 is a 5. Likewise, I could have kept the y to the negative 3 on the bottom, moved the exponent 2 from the top, okay, subtract the 2 from the bottom exponent, That would leave a 1 in the place of the y squared, and then we end up with a y to the negative 5, which is the same thing as y to the positive 5th power. Example 5, quotient rule with negative exponents, problem type 2. Okay, we just have more than one variable involved in the quotient rule. We have an n and an m, and then we have coefficients as well. We could separate these into individual fractions, where we group the like variables in one fraction. So the n to the negative 1 was on the bottom. We place it in its own fraction with n to the negative 6 on the top, and n to the negative 6 came from the numerator, so it stays in the numerator. M to the negative 9 was originally in the numerator, so it stays in the numerator. And so we've just separated these out into individual fractions, coefficients, m variables, and n variables. Well, 24 divided by 6 is simply a 4. We want, let's see, it doesn't say whether we want positive or negative exponents. What I'll do is I'll just move all of the variables to the top, to the numerator. So in other words, I'm going to keep the m to the negative 9 and apply the quotient rule, which means we move the 4 up to the top, and therefore we have to subtract it. Keeping the variables in the numerator, I keep the negative 6 on the top, and then I move the negative 1 to the top by subtracting it, so minus a negative 1 for the n. And this works out to be an m to the negative 13th power times an n to the, let's see, negative 5, because this negative 6 plus 1 is the same as a negative 6, or minus a minus 1 is the same as a negative 6 plus 1. So we get a negative 5. Okay. If you prefer an expression that does not have negative exponents, then we simply move the m to the bottom and the n to the bottom, and it becomes a positive 13 and a positive 5. B, if we separate it into individual fractions, coefficients, and common variables, could put the x's in one fraction, okay, so I've used the x and the 5 and the 20 and the x on the bottom, and now I write the y's in their own fraction. And now let's say we don't want an expression with negative exponents. What we can do is simply say pick out the variable with the larger exponent and move the one with the smaller one. First, we have the coefficients 5 divided by 20. We can write that as a 1/4. Nothing that concerns exponents with the 5 over 20. But now for the fraction with the x's, which exponent is larger, 9 or negative 4? Well, the 9 is larger. And so I'll move the smaller one by subtracting the 4, the negative 4, from the exponent on the top. That leaves a 1 in the place of the x to the negative 4. And now for the y's, the larger exponent is the negative 7. Alright, so keeping the y in the denominator means that we move the negative 8 to the bottom by subtracting it from the negative 7. That leaves a 1 in the place of the y to the negative 8. And so in the end, what we have is an x to the 9 minus a minus 4, which is an x to the 13th power. And then on the bottom, we have a y to the negative 7 minus minus 8, which is a y to the negative 7 plus 8. The 4 and the y are going to stay on the bottom. The x is going to stay in the numerator. So in the end, we get an x to the 13th of 4 times a y. Negative 7 plus 8 is a positive 1, and so we can just write a y with no exponent. And here is our expression reduced to an expression with only positive exponents. Okay, power rules with negative exponents. Power rule says that if we have a variable with an exponent and then it's applied, an additional exponent is applied to that, we just multiply the exponents. And in this case, the only thing different from what we did in chapter 29 is one of the exponents is negative, but we know how to multiply positive and negative numbers. And so there's not really a whole lot that's new here. Negative 4 times a 3 is a negative 12. And then from the previous pages, we learned that if we want a variable to have a positive exponent, then we just move it to the other side of the fraction. And so we end up with a 1 over z to the 12th. Okay. We could have done this differently. What we did here is we applied the power rule first, and then we dealt with the negative exponent by moving it to the denominator. Well, we could have done this in the reverse order and said, I want to deal with my negative exponent first. And so the z to the negative 4 inside the parentheses would stay inside. We'd move the z to the denominator and it would become a plus 4. And then we place a 1 in its original position. And now what we have is a 1 to the 3rd power. The 3 applies to everything inside the fraction, which a 1 to the 3rd power is just a 1. And then the 3 multiplies the 4 on the bottom. So we can drop the parentheses and we have a z to the 4 times 3. And we get the same result. Z to the 12th power in the denominator, or I should say a 1 over z to the 12th. Okay, in this case, the m inside the parentheses has a negative exponent, and then we apply an additional negative exponent, negative 2, to that. Well, the negatives sort of straighten themselves out if we just apply the power rule first. In this case, we have a negative 9 times a negative 2, and as we already know, a negative times a negative is a positive, and so we get a positive 18. And there's no need to move the exponent or the variable. It's already positive. C, we have several things inside the parentheses. Okay. I typically apply the power rule first. So I'll take the -4 and apply the -2 to that as an exponent. And then we have y to the -5th power to the -2 power. And I'm simply distributing this power of -2 from outside the parentheses to each exponent inside. And so finally, the z to the 6 would have a -2 applied to it as well. Okay. The -4 doesn't have an exponent written inside, and so what I'll do is I'll go ahead and fix this -2 on the outside by moving the -4 to the bottom, and the 2 will now become positive. I'll apply the power rule in the case of the y, and we get a y to the -5 times a -2, and that fixes the negative, the sign of each exponent, because a negative times a negative is a positive. And so the y sort of straightened itself out. And now for the z, we have a 6 times a -2 for its exponent. Carrying this a step further, we end up with a 10 for y, and it's positive. For the z, we end up with a -12. And then if we square -4, okay, there's no negative exponent here anymore. If we square a -4, that would be a positive 16. Minus times a minus is positive, and 4 times 4 is 16. And the negative is squared along with the 4 because it's inside the parentheses. So finally, the only other thing that we could do to this fraction would be to fix the exponent of the z and make it positive by moving the z to the denominator. So we move the z to the denominator, and the 12 becomes positive. Example 7. We have a negative exponent on the outside. And if we look inside, we only have z's for our variable. Okay. What we'll do is we'll use the fact that when we have a fraction with a negative exponent applied to it in this fashion as the power rule, what we can do is simply change the sign without really moving the exponent to the bottom. We can just change the sign of the 2 on the outside of the parentheses and flip the fraction on the inside. And so the 3z to the 6 moves to the numerator, and the 4z squared moves to the denominator. And now we no longer have negative exponents. At this point, we simply apply the power rule, which gives us a 3 squared, a z to the 6 times 2. The 2 applies to each number and exponent on the inside. Okay, so this is 4 squared, z squared squared. And the 4 stays on the bottom, and the z squared stays on the bottom. We just simply multiply its exponent by 2. 3 squared is a 9. 6 times 2 is 12. 4 squared is 16, and 2 times 2 is 4, leaving us with a z to the 4s. And finally, we can combine these z's through the quotient rule, which says that we subtract the exponents when the variables are divided. So we have a 12 minus 4. And so in the end, we get a 9z to the 8th power over a 16. If you wanted to take this in a different direction, an alternate way we could have went is we could have applied the quotient rule before we applied the power rule. We could have written this as a 3 over 4, nothing changes with the coefficients, but then we could have written z to the 6 minus 2. And then we would have had a 3 times z to the 4th over 4, and then applied the power rule to the 3, the 4 as the exponent, and then the 4, the number on the bottom. And that would give us 3 squared z to the 4 times 2 over 4 squared, which is 9 z to the 8th over 16. The same result, we just did the steps in a different order. Okay, so from here on out, what we'll say is we want to avoid negative exponents. Okay, in that case, what we could do is we have a positive 2 on the outside of the parentheses. On the inside, we could go ahead and get rid of this negative exponent. Okay, and we can do that by applying the quotient rule in a way to where we keep the variable with the larger exponent where it's originally at. So we keep the x to the 3rd on the bottom because a negative 3 is smaller than a positive 3, and we remove the x to the negative 3 and subtract a negative 3 from the x exponent on the bottom. Quotient rule. That's all we did there. 3 minus a minus 3 is a 3 plus 3. We keep the 2 outside parentheses because we haven't applied the power rule yet. And so finally on the inside we have an x to the 6th power. And there's nothing left to do other than to apply this power of 2 to the exponents on the inside. And so we get a 3 squared, an x to the 6 times 2, which turns out to be a 9 over an x to the 12th power. Okay, example 8. What we can do to avoid negative exponents is, let's see, a lot of different ways we could attack this, but what I'll say is first we'll fix the exponent outside the parentheses. We'll go from a negative 3 to a positive 3, and we can do that as long as we switch the numerator and denominator. We flip the fraction. Okay, so when we flip the fraction, because we change the sign of the 3, we do not change the signs of the variables inside. Okay, we simply move them and keep their original exponents. Okay, now that the 3 is positive, we'll work on the exponents inside the parentheses. Alright, the coefficients 2 and 3 do not share common divisors, so we'll leave that as 2/3. Now what we'll do is we'll apply the quotient rule to the x's and the y's, and we'll keep the variable with the larger exponent where it's at. And so the x to the 4th has the larger exponent in terms of the x's, and then in terms of the y's, the y to the -1 has the larger exponent. And so we'll keep both of them on the bottom, and so if we keep the x and y on the bottom, that means we subtract the other exponents from their exponents. So 4 on the bottom minus the -4 from the top. Let's see if I can separate that a little better. And then the -1 on the bottom, we would subtract a -5 from the -1 on the bottom. And we move this y and x to the bottom, and so what that does is it simply leaves a 1 in their places. What does this work out to be? We get a 2 on the top and a 3 on the bottom for the coefficients. 2 times 1 times 1 is still just a 2, so we don't need to rewrite the 1's on the top. And we need to carry out the addition and subtraction with the exponents on the bottom. And that's going to give us a 4 minus minus is a plus. A 4 plus 4 is an 8. And then for the y, we have a -1 plus 5. That would be a 4 for the y. And so now we have it set up to where when we apply the product rule, we get positive exponents. And so we write 2 to the 3rd power on the top, and everything's just going to stay where it's located. The 3 is going to stay on the bottom. We just apply a power of 3 to it. X is going to stay on the bottom, and we multiply its exponent by the 3. And now we apply the 3 to the y, and it multiplies the 4. So in the end, we get 2 to the 3rd power on the top, which is an 8. 3 to the 3rd power is a 27. 8 times 3 gives us an x to the 24th, and y has an exponent of 12. 4 times 3 is 12. Alright, so we'll follow the same procedure that we did with the previous one. We have a -3 on the outside of the parentheses. We'll write it as a positive, and in doing so we move the numerator of the fraction inside to the denominator, and we move the denominator to the numerator. We flip the fraction, so everything just moves. Changing this negative to a positive, we just move everything on the inside without changing any of the signs of the exponent. So we have a 3x to the 3rd and a y to the -1 on the bottom now. We move the 4 to the top, and the signs of the exponent stay the same. We moved them because of this negative changing to a positive. Alright, so now we want to apply the quotient rule inside to combine the like variables. 4 and 3 do not share a common divisor, so we can't simplify the coefficients. And now we simply pick the variable with the larger exponent. and that would be the 3 for the x on the bottom, and then that would be the y with the -1 on the bottom. So for the x, we take the -3 from the top and subtract it from the bottom, and then for the y, we subtract the -4 from the top, and that's just going to leave 1's in the places of the x and y on the top. Four times 1 is simply a 4 on the top. We didn't really need to put those 1's there. A 3 minus a minus 3 equals 3 plus 3, which is 6. So this becomes an x to the 6th power on the bottom. And then a -1 minus a minus 4 for the y is a -1 plus 4, which turns out to be a positive 3. And now all of our exponents are positive, including the exponent on the outside of the parentheses. From here on out, we will not have to move anything from numerator to denominator or vice versa. We just simply apply the power rule, which says that we raise the 4 to the 3rd power, the 3 on the bottom to the 3rd power, multiply the 6 and the 3, multiply the exponents on the bottom by 3, okay, carry out the exponents. We have a 4 to the 3rd, which ends up being, what's that become? 4 times 16 is 40 plus 24, 64. 3 to the 3rd is 27. 6 times 3 is 18, so we get an x to the 18th power. And then 3 times 3 is 9, y to the 9th power. And this is as far as we can go. And we have positive exponents. The only other thing we could do would be to move the x and the y to the top, but that would give us negative exponents for the x and y. So here we have our last couple examples for the chapter. A lot of different things mixed in together. We'll have to apply all 3 rules for exponents, product, quotient, and the power rule, and we have some negative exponents mixed in. Alright, the first thing that needs to be dealt with is this power of -3 on the outside of this second set of parentheses. And you probably notice that we have a v and a w inside each set of parentheses. We cannot combine those variables until we've dealt with the exponents on the outside of the parentheses. In other words, it's sort of like an equation. We have to get rid of the parentheses first. Alright, so nothing's going to happen with this v to the -4 and this w to the 5th power. We're going to leave it alone for now. What we will do is change the -3 to a positive one, and we'll flip the fraction inside that set of parentheses. Okay. Now what we'll do is we'll apply the 3, the power rule, to the second set of parentheses, and still we do not mess with the first set of parentheses. We're going to get a w to the -1 times 3, a 3 to the 3rd power, a u squared times 3, and then a v to the 3rd power. If a variable does not have an exponent written, and there's an exponent outside the parentheses, then that variable just simply adopts that exponent. So the v just simply adopts the positive 3 from the outside. It didn't have 1. Okay, it's just a 1, and 1 times 3 is 3. So now what we can do is drop all of the parentheses. Okay, for this set of parentheses, there's simply a 1 as the exponent on the outside, and here, same case. This, you can now look at this or interpret this as a 1 as an exponent outside the parentheses. Whenever that's true, we do not need the parentheses anymore. We can simply take everything and write it out side by side or within the same fraction. So negative 1 times 3 gives us a w to the negative 3 power. 3 to the third power is 27. U to the 2 times 3 is a u to the 6th power, and then we have a v to the third. Okay, now everything is combined into one product and one quotient. Alright, we only have one coefficient, and that's a 27 on the bottom, and so we'll keep it there. We can't reduce the 27. But now we have a v on the top and a v on the bottom. We keep the v with the highest exponent in its place, and we drop the v with the lower exponent and subtract its exponent from the other. So the 3 on the bottom gets a negative 4 subtracted from it, minus a minus 4. That takes care of the v's. And now the u has a power of 6. The 6 is positive, so the u is happy. We don't have to move it, and there are no u's to combine it with in the numerator. And now for the w's, we have a w times a w. We apply the product rule, which says that we add the exponents. So this is a 5 plus a negative 3. So in the end, we get a w squared, a v to the 7th, and a u to the 6th. And for this problem, this example, this would be the end of the road. Okay. Alright, so the biggest thing to do first in this case is to notice the exponents on the outside of your parentheses. Just like an equation, get rid of the parentheses first, and in order to do that, you have to apply the power rule. Okay, so we distribute this negative 2 to all of the exponents on the inside. We have the coefficient negative 3, and we just write it in its own set of parentheses and put a negative 2 on the outside. But then the other variables, we can multiply their exponents by negative 2. The y didn't have its own exponent, or at least there wasn't one written. It's just a 1, so the y just adopts the negative 2 from outside the parentheses. And then the z squared has a 2 for an exponent, and we multiply that by the negative 2 from the outside. So we can drop these parentheses, and then for the second set of parentheses, there's no exponent listed on the outside, and so we simply interpret it as a 1, and therefore we can drop the parentheses without carrying out the product rule. Alright, only thing I'm going to move in this next step is the negative 3. I'm going to move it to the bottom, and so I can write this as a negative 3 squared, which is a little less confusing. And now I'll carry out the multiplication inside the exponents for the rest of the variables. We've taken care of the negative 3. I've multiplied the exponent for x, 3 times negative 2, and I get a negative 6. There's another x in the numerator, and so what I'll do is I'll move it closer to the first x variable, and I'll cross it off the list. And then I have y's on the top together. I have one with the exponent of negative 2, and then I have another with an exponent of positive 2. And then I only have one z variable, and so I'll carry out the multiplication inside its exponent and write a negative 4. 2 times negative 2 is negative 4. Alright, on the bottom we have a negative 3 squared. Negative 3 times negative 3 is a 9. I have an x times an x on the top, and so that becomes a negative 6 plus a 1. This x has an exponent of 1. When you multiply two variables, you add their exponents. For the y, we have y negative 2 plus 2. And then the z, I could do a little work to the z just by simply moving it to the bottom, and that will make its exponent positive. The x ends up having a negative exponent. A negative 6 plus 1 is negative 5. The y ends up with an exponent of 0, negative 2 plus 2. And the 9 and the z on the bottom they're still happy. We don't have to do anything to them. They're just along for the ride at this point. The y to the 0 ends up being a 1. So we can cross it out. And then we don't have to list the 1 in the numerator, because 1 times anything is just 1. But then the x to the negative 5 can be moved to the bottom, and that makes the 5 positive. And so we kind of do need the 1. There's nothing left on the top to multiply the 1. So we just have a 1 over a 9z to the 4th, x to the 5th. And this is the end of the road for that example. Okay, so hopefully these were enough examples to get you started on your homework. Feel free to ask any questions that you might have about some of the problems that we worked in this chapter. This video is already run for about an hour, and so if you need me to perhaps work it slower or work it in a different way, like I said, come by my office. Thanks for watching.